In this video lesson, we are going to continue with our standard integral of functions. In our previous class, I taught you the standard integral of powers of a variable function, the standard integral of exponential function. I introduced the standard integral of trigonometric functions also, and we treated the standard integral of cosine function. In this video lesson, we are going to continue from the standard integral of sine function. Please, if you are yet to subscribe to the GMAETS 41 YouTube channel, please do so. Kindly click the subscription button, turn on the notification bell so that you can follow up with my updates. You will be personally notified whenever I upload a new video content. Alright, let us get to business. The standard integral of trig function. The second is the one we are going to look at, which is that of sine. So that takes us to 3b because we stopped at 3a in our previous class. So we have the function given y to be integral sine f of x. We are to integrate with respect to x. So as usual, we are going to identify our major function and then identify our minor function. And remember the general approach. We shall integrate the major function and then divided by differentiate the minor function. So let's do this and say the major function here is sine. The minor function is f of x as usual. So to obtain the integral of sine, I'm going to ask myself in differentiation, which function did I differentiate to get sine? And I will tell you this. Under differentiation, we differentiated cos to produce the function sine. However, we didn't get positive sign there. What we got was minus sine. So once again, if you differentiate cos, you would get minus sine. Therefore, if you integrate minus sine, you're expected to get cos. If you integrate minus sine, you're expected to get positive cos. Because it was positive cos you differentiated to get minus sine. So integrating minus sine, you get positive cos. But please take a look at this. What we are integrating as the major function is positive sine, not minus sine. But I said that if you integrate minus sine, you are expected to get positive cos. So if in this case I am integrating sine, that is positive sine instead, it means that the minus in that sign would have been transferred to cos, giving us minus cos, so that if you now integrate the positive sign, your result will be negative cos. And of course, that is the standard integral of sine. If you integrate positive sign, you are going to get minus cos. Of course, it's going to be cos of the minor function f of x, then divided by, we will differentiate the minor function f of x, which I am going to simply write f prime of x. This is the derivative of the minor function. It's the same as d dx of f of x. Alright, I'm using this, this prime shows the first derivative of this minor function. Then I will put plus the constant of integration. I will add it up. Alright, so this is the standard integral of this function. Let us take some example. Imagine you are given y to be integral sine x. Now I'm going to show you, because this is the standard usually quoted when teaching the standard integral of sine. But I've always said something like this, okay, it's good, alright, but just give us something like 30% knowledge or so. We need something much more fundamental, which can help us to cover up the reversal of chain rule in the process of integration. Where we'd say let u be equal to this or that. This standard helps you to avoid that technicalities. Okay, so let us see the standard integral of sine. What are we going to? Sine x. What would it give to us? This would be y equal to, we will integrate the major function sine, giving us minus cos. Minus cos of the minor function x. Then divided by, we shall differentiate the minor function x, and if you differentiate x with respect to x, you will get 1, so we'll put plus c. And so if you simplify this, this is minus cos x, Alright, if you divide a term by 1, you are going to get that term. So this is simply minus cos x plus c. And of course, no wonder we will be told generally that if you integrate sine, you are going to get minus cos x. That is, if you integrate sine x. So you see the funny thing that happened here, right? Going by this standard, usually we are not being told that this x was differentiated. Again, that limits, that reduces our understanding of integration. Anyway, that's just what I feel, because I experienced such challenge learning integration, during my time. And that is why I don't like using this as standard of teaching. I prefer using f of x instead, where I would tell my audience that they should remember that in each case we need to divide by the derivative, by the differentiation of the minor function. Okay, let us look at another example. You're given y to be integral sine, open bracket, 2x raised to the power 3 minus 5, okay, dx. So how do we integrate this? The solution is simple. The major function is sine. If we integrate this major function according to the standard, integrating sine will give us minus cos. So this is going to be minus cos of the minor function, 2x raised to the power 3 minus 5. Then we shall divide by, differentiate the minor function 2x cubed minus 5. If I differentiate 2x cubed, it's going to give me 6x squared. And then differentiate this 5, you get 0. So that goes off. We're going to put plus c. And that is that about the standard integral of the function sine under trig. We shall move on to another function. Under trig, we'll consider 3c. This time around, I want us to consider the integral of sec square. So we have y to be integral sec square f of x dx. So what are we going to get? Remember the procedure. Ask yourself, under differentiation, which trig function did you differentiate to get sec square? And the answer is tan. We differentiated tan to get sec square. Therefore, if you integrate sec square as a major function, you are expected to get tan. So this is going to be tan f of x, then divide by derivative of that f of x. Introduce your constant of integration. So take note of that. Now let us take an example of this. We have y to be integral sec square of, let's say, 5x, and then we have to integrate this with respect to x. Simply, we have that y is equal to, identify your major function, which is sec square. Are you following? Or square sec. Identify the major and then integrate it. So what is the standard integral of sec square? Like you have there, is going to be tan, and so we have tan of the minor function 5x. We are going to divide this by the derivative of the minor function 5x. If I give you 5x to differentiate, you are going to get 5. And so we introduce our constant of integration. Let's consider another example, y to be integral. We're going to have sec square. So I'm going to get x raised to the power 4. Let us integrate this function with respect to x. Once again, it's a direct concept. Simply identify your major function. If you integrate this function, you are going to get tan. So integral of this major function gives us tan. Tan what? Tan of x raised to the power 4, the minor function. And then divided by, we shall differentiate the minor function x raised to the power 4. Differentiated will give us 4x raised to the power 3. And then we shall add the constant of integration. And that is how we handle the standard integral of sec square. Alright, we shall move on to another function, again on trig, and we'll be looking at the standard integral of the function sec f of x tan f of x. So we have our fourth standard integral of trig function, y equal to integral sec f of x tan f of x dx. So what's the standard integral of this function? Alright, we are going to recall that under differentiation, we differentiated sec f of x to get this sec f of x times tan f of x. And therefore, if we integrate this function secant, we are going to get that function we differentiated to get it, and that function is sec f of x. And so we are going to divide this by derivative of the minor function. The minor function is this f of x, so we're going to have f prime of x, that is, differentiate the minor function f of x with respect to x, put plus c. So what have you learned here? It's simple. If you integrate secant, you are going to get what? Sec. It follows the same procedure as per. You need to divide by derivative of the minor function. A quick example here, y is equal to integral sec 2x squared times tan 2x squared. And so the result is going to give us standard integral of secant is going to produce what? Sec. So this is going to be sec of f of x, sec the minor function. And the minor function here is 2x squared. So you just write one of them, 2x squared. We're going to divide by differentiate the minor function. 2x squared, if you differentiate it, you're going to get 4x and then plus c. So this is the result. Let us move on straight to another standard integral of trigonometric functions. Alright, so the function we now have here is that y is equal to integral square cosec f of x. Square cosec f of x. The major function here is this cosec square, and the minor function as usual f of x. So what is the standard integral of this term? If you integrate cosec square f of x, you are going to get minus cot f of x. Then divide by, differentiate the minor function f of x, then add your constant of integration. So did you take note of something? Standard integral of cosec square will give you what? Minus cot. The reason is, under differentiation, you differentiate cot. You differentiate cot to get minus cosec square. To get what? Minus cosec square. So if at all we want to integrate a cosec term to get positive cot, then we should be integrating negative cosec square, that's minus cosec square, to obtain what? Cot. Now in this case, we are integrating cosec square, no longer minus of it. It simply means that the minus would have been transferred to cot. So that integral cosec square would now produce minus cot. Similar to what you saw under the integral of sine, which produced minus cot for us. Okay, let's look at a quick example here. If you're given y to be integral, say cosec square of x raised to the power minus 4, and then you are integrating with respect to x, your result is going to give us, watch, our major function is cosec square. Integral cosec square will give us minus cot. So I'm going to have minus cot of the original minor function, which is x raised to the power minus 4. Then we shall divide this by, differentiate this minor function, x raised to the power minus 4. And you will get minus 4 x raised to the power. Remember, you are subtracting 1 from this under differentiation, so it becomes power minus 5. And so we are going to add plus c, our constant of integration. So that is it. Once again, integrate cosec square x raised to the power minus 4. Integral of this major function cosec square will produce minus cot. Of course, remember to always add or attach your minor function. Then divided by, differentiate the minor function. If I give you x raised to the power minus 4 to differentiate, because you know how to use powers of a variable to do your differentiation. We've treated that under differentiation. You can actually search through our playlist, and then you would see a video lesson on standard derivative. So if you differentiate x raised to the power minus 4, the minor function, you are going to get minus 4 x raised to the power minus 5. So this takes us to the sixth trig function, y to be equal to integral, this time around, cosec f of x times cot f of x dx. So I want to find the standard integral of this function. And the standard integral of this function is minus cosec f of x divided by, we differentiate a minor function as usual, and then add plus what? C. So you see that this whole standard integral follows a particular pattern. Integrate the major function divided by differentiate the minor function, just like I already indicated here earlier. Now, what have we learned from here? Simple, that the standard integral of cosec cot, I take that again, the standard integral of cosec cot will give you minus cosec. Minus cosec. So have that in mind. Are you following, right? Because under differentiation, we differentiated positive cosec. Positive cosec. That's if you differentiate cosec, it will give you minus cosec times cot. So if you are now integrating minus cosec f of x cot f of x, it will produce positive cosec for you. Alright? But then, if you are integrating positive cosec f of x cot f of x, that negative which appeared from differentiation would have been transferred to what? Cosec f of x. Once again, the analysis of this function is similar to what we did in cosec square. It's also similar to what we did in the integral of sine of a function. Alright, as an example, let us take a look at this. If I give you y to be equal to integral, okay, the simplest cosec cot function you could see, which is cosec x times cot x dx. What would this produce? The integral would give us, identify the major function, cosec cot. So if you integrate cosec cot, what would you get? It will produce minus cosec. Minus what? Cosec. And of course, you know, trig function cannot just stand like that. There must be an angle in front of it, which is this x. Are you following? All this f of x I've been dealing with. So this is going to be x. I'll attach the minor function. Then divided by, we shall differentiate the minor function, which is x. If you differentiate x with respect to x, you get 1. Then attach a plot c. Simplifying this is simply minus cosec x plus c. And that's the standard when you are learning this integral of cosec cot function using simply x raised to the power 1. Okay, another one. If you have y to be integral cosec, let's say x raised to the power 2, then times cot x raised to the power 2 dx. Then the integral function will give us standard integral of cosec cot, which is the major function here, will give us minus cosec, then x squared, the minor function, divided by differentiate the minor function. So you have x squared as the minor function. If you differentiate x squared, you are going to get 2x. So over 2x, attach your constant of integration. Good, so I'd like to put it a stop for standard integral of trig function. We are not done with the standard integrals I'd like you to learn. We are still going to consider the standard integral of secular inverse function. Also that of hyperbolic function, alright, where you have the integral of sine of a function, cos of a function, sec square of a function. So the standard integral still continues, alright? But I'd like us to put a stop to that of trigonometric function with these 3f. We've considered 6 of them. Before we move on to other functions, I would like to quickly say this. Did you take note that we did not consider standard integral of tan f of x, that is tan of a function? Did you notice that? Did you ask yourself, why is it that I use the word neglected, or I didn't talk about standard integral of tan of a function? Alright, let me just tell you that tan of a function does not have standard integral that follows the way the other trig functions which we've considered took. If you look at the trig functions from 3a down to 3f, we considered, okay, that of cosine, sine, or of course that of sec square, that of sec, that of cosec square, and then that of cosec cot. You notice that they followed one particular pattern. And what was the pattern observed? If you integrate one of the trig functions, it's going to produce another trig function. That was the pattern observed. for each of the 6 trig functions considered so far. Unfortunately, tan does not follow that pattern. If you integrate tan, what you're going to get is not a trig function at all. Alright, one of the reasons is this. Under differentiation, and I would like you to refer back to my differentiation video. Under standard derivative, we did not differentiate any trig function to get tan. I repeat that. We did not differentiate any trig function to get what? Tan. Therefore, you cannot integrate tan to get any trig function. I hope you get that right. So that is one of the major reasons. The other reason I am going to explain that when I teach you use substitution technique of integration. But until then anyway, let's be done with our standard integral. Please remember to subscribe to my YouTube channel here at GMAETS 41. There are still many more to come your way. Alright, we'll be continuing with the standard integral of circular inverse function.